All right, section 10.5, we are talking about the last of the four conic sections. We'll be dealing with hyperbolas, and I want you to leave today with the ability really to do two things. I want you to be able to take the equation of a hyperbola and sketch the graph, including the foci, and then I want you to be able to take information about the hyperbola, like foci and vertices, and then write the equation. So here we are. You've been seeing this slide as we've made our way through this chapter. We're now at the last section as far as learning about the conic sections. The actual last section of this chapter will be translating the conic sections, moving them from the origin as the center. We'll see if we get to that after the test. So I thought, some people have the question, well, where do these appear in real life? Just real quickly, I thought I would provide you with a few examples. As you can see here, gears in a motor of some kind, they have this hyperbolic shape. The actual hyperbola equation is known as the sonic boom curve because the actual sonic boom, you might know that that's when we exceed the sound barrier, when a jet or some other vehicle goes faster than the speed of sound, it creates this sonic boom. And that sonic boom is actually produced if the jet, in this case, flies completely horizontal to the ground. It produces a hyperbolic shape. Kind of interesting. And then you may have seen these around nuclear reactors. These are nuclear cooling towers, and they have this hyperbolic shape as well. So with all that said, and there are other examples, certain orbits of comets orbiting around the sun would follow a hyperbolic orbit pattern. But what we're going to do is take equations like this one, and we're going to learn how to sketch the graph. So I'm going to be drawing some similarities and differences between what we already know about ellipses. Well, here is a difference right off the bat, no pun intended. But if this were an ellipse equation, what would this sign be? Yeah, it would be plus. Well, hyperbolas, that's why I said no pun intended, the difference between hyperbolas and ellipses is this is always minus. Difference, minus.
Oh, no.
Okay. So, that went over well. So, here's a similarity. With ellipses, we said that before we could graph this, we need to convert it into its standard form, which meant it had to equal 1. That's also true for hyperbolas. So, the first thing I'm going to do is divide everything by 64. So, this is just like you did with ellipses. So, my standard form hyperbola equation in this case is going to be x squared over 16 minus, always minus for hyperbolas, y squared over 4 equals 1. And you can put this on your graph paper if you want to. In my next slide, I'm actually going to show you how to graph this equation. Here is a big difference between ellipses and hyperbolas. As far as the denominators go, for a hyperbola equation, this first denominator is always a squared. The second denominator is always b squared. The denominators never change. They're fixed. The first one is always called a squared. The second one is always called b squared. Here's what does change from one hyperbola equation to another. It's these numerators. And the location of the numerators is important. It's good information to tell us how this graph is actually going to look. All right? For example, the fact that x squared comes before y squared in this equation, x squared is first, that tells me that I'm going to have a hyperbola, and you don't have to write this, I'm just going to do a rough sketch. You can think of a hyperbola as two parabolas that open opposite each other. Well, the fact that x squared comes first in the equation tells me that I'm going to have a hyperbola that looks something like this. I'm only going to cross the x axis. So rough sketch, it's going to look something like that. Since x comes first, I only cross the x-axis. Okay? If, you don't have to write this, if my equation, I'll leave the denominators like they were. If my equation looked like this, you notice that I just switched places with x squared and y squared. Well, now I've got a hyperbola that's going to open up and down. Just like the y-axis runs up and down, y comes first in the equation, so I'm going to have parabolas that open up and down. The x-axis runs left and right. In my equation, x comes first, so I'm going to have parabolas that open left and right. So pay close attention when you're looking at hyperbola equations as to which variable comes first. And that will tell you what your graph will look like in general. Okay, so with that said, let's go ahead and sketch the graph of this. Okay. The way we start out graphing this, it's going to look a lot like what we do with ellipses. I'm going to do the square root of 16, which is 4, plus minus, and I'm going to put plus minus 4 on the x-axis. So that looks a lot like what we did in the previous section with ellipses. All right, and then I'm going to do the square root of 4, which is 2, plus minus, and I'm going to put plus minus 2 on the y-axis. So that should look really familiar to you. If this were an ellipse equation, meaning it would have to be plus here, I would just draw an oval shape around these 4 dots. Well, for hyperbolas, by the way, you're going to need a straight edge. So if you don't have your ruler with you, just find something that you can draw straight lines with. You're going to need to draw a couple of straight lines. That could be an ID card, something out of your wallet like that. It really doesn't matter, just as long as you can use it. It's the edge of your book. We're going to draw a couple of lines. These 4 dots for hyperbolas are going to be used to form a rectangle. Okay, so we're just using dotted lines to form a rectangle around these 4 points. It's a dotted line because it's not really part of my graph. It's just this is going to be a tool to help me draw the graph of the hyperbola. And this actually has a name I want you to be familiar with when you see it in instructions. This is called the interior rectangle. Interior rectangle. Okay, now is where your straight edge is going to come into play. Okay, you don't really need a straight edge to draw this box, but you do need a straight edge to draw a couple of lines. And here's how we're going to draw them. You're going to line up these opposite corners of the box and the origin, because the origin is going to be the center of all your hyperbolas in this lesson. And I want you to draw a dotted line that goes through those opposite corners and the center, the origin. Yours will be really straight. I'm just going to freehand mine. So we're going to draw one with going this way, and we're basically just going to make an X. So line up the opposite corners and the origin, 3 points, and they should cross right at the origin. Well, you're already familiar with what these lines are. We've dealt with these quite a bit in the past. These 2 lines represent asymptotes. Lines that our graph will always approach but never touch. All right, everybody with me so far? All right, so I notice in my equation that x comes before y. And we said in the previous slide, whenever x is the first variable, then that's the axis that I'm actually going to be crossing with my curves. So I'm going to draw a curve using these asymptote lines. I'm going to draw a parabola that goes through this end point of the interior rectangle. So it's going to go through 0, -4, and then approach the other asymptote. So there's one parabola. So remember, a hyperbola is really just two parabolas. So I'm going to do the same thing on this side. All right, so far so good. Now the only thing left as far as the graph is concerned is I need to plot the foci. Well, let's just review for a second. If this were an ellipse, meaning I would have this as plus and it would be an oval shape, how would I find the foci? Okay, he said, why? It said c squared equals a squared minus b squared. That's what we would have used if this were an ellipse. Remember that? Well, what do you think we're going to use since this is a hyperbola? Yeah, it's just the opposite. So here's one of those cases where you really have to keep this straight. For plus, for ellipses, you use minus in this formula. And when it's minus, indicating hyperbola, you use plus in this formula. In other words, we're going to be using the Pythagorean theorem. All right, so let's see if we can find out where the foci go. So c squared is, a squared is always the first denominator, in this case 16. B squared will always be the second denominator. C squared is 20, and I need the decimal form of the square root of 20, and I'll save you a little bit of time. You might want to go ahead and grab your calculator because you're going to use it. Should be 4.5. So do you remember what C stands for when we were talking about parabolas?
Distance.
Distance from where to where?
Vertex to the origin.
Okay, I agree with the vertex. It's a distance from the vertex to the, anybody remember?
Focus.
The focus, all right? Well, for hyperbolas, C represents the distance from the center to a focal point. So from the center, going right 4.5 places, I'm going to put a dot. Remember, focal points always go inside the mouth of the parabola. Well, I've got two of them I've got to plot. So I'm going to do the same thing going left C places, 4.5 places. So in ordered pair form, I would represent the foci as plus minus 4.5 since they're on the x-axis, 0. All right, any questions so far? Any questions? Let me give you one more term that you will see from time to time, and that is there's a line that connects these vertices. Okay, I'm going to highlight it. In this case, my vertices are 4, 0. It's where my graph crosses the x-axis at 4, 0 and -4, 0. Well, that line that connects the vertices, it has a name, and it's called the transverse. I'm going to see this again. Transverse axis. So if you're given information like this, you have a hyperbola that has a horizontal transverse axis, then you know that your graphs have to open left and right. Think of the x-axis being horizontal. If you're told that the transverse axis is vertical, then you know that the parabolas have to open on the y-axis because the y-axis is vertical. All right, so that completes the entire graph. Any questions so far? I'm going to give you one to try. Okay, I want to see if I'm going to stop the recording And then I want to see if you can come up with the entire graph, including the foci of this equation. Okay, question?
Do we need to draw the transverse axis?
No, you don't have to. The reason why I showed you that is because sometimes in instructions you're given information about the transverse axis. I just wanted you to be aware of what it means. Let's take a look at what this graph looks like. This is your complete graph, including the foci. You need to make sure you draw the interior rectangle, draw the asymptote lines, and always place the foci inside the mouth of the parabolas. Some people have a bad habit of plotting the foci and then drawing through the foci. But we know that focal points go inside the mouth of the parabola, and that's not possible if we draw through them. Okay, so just remember that. That's just another common mistake. How many of you got this right? You use c squared equals a squared plus b squared.
And you get the square root of those numbers or the 16?
16.
Yeah, a squared is 16, and b squared is 9. So you add those together and you get c squared is 25. So c, which is the distance from the center to one of the focal points, is 5. So you go up 5 and then down 5. Okay? Yeah.
Do we need to write that down? Foci.
In ordered pair form?
Yeah.
Yes, if you would, that would be great. Is my transverse axis horizontal or vertical? It's not something you're going to have to answer. I just want to make sure you understand it. How long is it total? See, it's from here. It's from 0,4 to 0,4, so it's 8 units. What is the variable that I associate to measure the distance from the center to a vertex? What variable do I use to show that? Is it, Brent? That would be a co-vertex, which we don't have in this case. So what do we, when we had ellipses, what did we use to associate vertices? Which variable? A. All right. So what is the distance from the center to a vertex? How many units? 4. Okay. So how would you describe in equation form the total length of the transverse axis? If A, yeah, she got it. She said 2A. If A is 1/2 of the distance, and you want to find out what the total distance is, it's 2A. That's how you find out what the measurement of the transverse axis is, if you were ever asked. All right? You get it? Make sense? Any questions? That's all I have in the way of graphs. Usually the graphing of these is pretty easy. Just one more time, pay close attention to the variable that comes first, and that's going to tell you which axis you're going to be crossing with your two parabolas. Okay, I wouldn't say that you have to write all of this. What I'm going to do is a couple of examples that help you with numbers 23 through 26. So if you just watch or read the instructions for 23 through 26 in the assignment, and just in your notes, just put this. You have a focus at 4, 0, and one vertex at -2, 0. And the rest of that you can read from your book. And again, you're assuming for all your hyperbolas in this lesson, all of them are centered at the origin. So you don't ever have to worry about that. Okay, well, based on what we're told, the location of a focus, by the way, where would the other focus be located? -4, 0, if we're centered at the origin. So we'd have one focus on either side, same distance away. And where's the other vertex located? 2, 0. Okay? All right, so what do we know about how this hyperbola opens? Does it open up, down, or left, right? Left, right. Okay, so what I'm going to do is I'm going to show just using variables the hyperbola equation that represents the hyperbola that opens left, right. Notice I led with x squared. Okay? Now it's going to be our job, just like we did with ellipses, to find out what a squared and b squared are, put them in there, and then we'll have our answer. So remember, for hyperbolas, I'm going to use the Pythagorean theorem. Well, I have a question for you. Not c squared, but what is c? What is the distance from the center, the origin, to one of the focal points? What is that distance? 4. Everybody see that? The focus is located at 4, 0, and if you're going from the center, that's 4 units. Well, if c is 4, what's c squared? All right. What is the distance from the center to a vertex? 2. And that's what a is. A, the variable a stands for how far is it from the center to a vertex. Well, if a is 2, what's a squared? So what's b squared? B squared is 12. So now we're ready to finish off our answer. A squared is 4. B squared we just found is 12. And that is my answer for this first example, this first equation. Any questions? On the next slide, I've got one for you to try. Okay, we'll see if you can, again, you don't have to write all the information, just write down the focus and the vertex and see if you can come up with the equation. Now, here's my question. I've got a question for you. Is the transverse axis vertical or horizontal? Is the transverse axis in this case vertical or horizontal? See, vertical. Very good. Which tells me that the graphs will open how? Up, down. Okay? Which tells me also about the equation. Which variable will come first? X squared or y squared? Very good. You guys are getting this really well. So I'm going to go ahead and write this part. So it's going to be our job to find a squared and b squared, and we'll be done. All right, so what is the distance from the center to a focal point? In other words, what is c?
5.
C is 5. What's c squared? Okay, c squared equals, and what's a? That's the distance from the center to a vertex. A is 3, so what's a squared? So then what's b squared? All right, and so we're about ready. A squared is 9. B squared is 16. We got this correct. Do you have any questions about it? Yeah? Which variable comes first?
No, which one goes first? Like the
Well, for hyperbolas, this is always a squared, and this is always b squared. They don't ever change. Okay, anybody else? How many of you switched x squared and y squared? That's a common mistake. Yeah, that you wrote the equation, but you switched them. Anybody? You did? Did you understand it now? Okay, question.
So how do you know which one you're trying to watch on that?
It's based on the vertices. We must be crossing the y-axis. And so y needs to come first. All right, I'm almost out of time, and you're on par with the rest of the classes. So let me give you the assignment. And this is a little bit unusual. I try to give you examples of all of the problems that you have to do. Well, that's true except for those last 3. Those last 3, I'm going to stretch you just a little bit. Now, I'm going to give you some video help if you want to watch the video that's separate from this. But if you don't watch the video, these are going to be, I mean, hopefully you'll be able to do them, but the information you're given is just a little bit different. The rest of these, I gave you examples in class that are pretty much just like what you're going to be doing. All right, good job. Work hard on these. Let me know. Send me an email if you have any questions.